Hello friends, in this video we are going to see design of two-way slab in limit state method. Question is, design a RC slab of room size 5 meter into 3 meter. The thickness of supporting wall is 300 mm. The live load of slab is 2.5 kN per meter square. Use M20 and FE415. Condition: two adjacent edges are discontinuous and other two is continuous. So LY long span is 5 meter, LX short span is 3 meter. Supporting wall is 300 mm. Live load is 2.5 kN per meter square. Fy is 415, FCK is 20. First step is finding dimension. You must find effective depth, overall depth, effective span, and width is assumed as 1000 mm. Effective depth formula is Lx by 35. Answer is 85.71, rounding it 100 mm. Next is overall depth. Formula is effective depth plus d dash. D dash is clear cover. Clear cover is 50. Answer is 150 mm. Next is effective span. Formula is L plus effective depth or L plus support width. Whichever answer is lesser, we take it as effective span. So 3.10 is less. So this is effective span answer. Step 2 is load calculation. Self weight equal to breadth into overall depth into 25. Live load is 2.5 given in the question. Floor finish, we assume floor finish as 0.75. So the load answer is 6. Adding self weight, live load, floor finish, we get 7 kN per meter square. Next step is ultimate load calculation. Formula is 1.5 into load. So the answer is 10.5 kN per meter square. Step 3 is ultimate moment and shear force. Ultimate moment formula is in IS456 page number 91. So in page number 91, IS456 2000, here is the formula. Alpha x and alpha y value is taken according to the given condition. The condition is two adjacent edges are discontinuous and other two is continuous. So here in IS456 page number 91, they have provided a table. In this table, referring to the condition, here two adjacent edges are discontinuous. Here it is given. This is our condition given in the question. So in this we have to take the value of short span alpha x by referring the answer which we have got Ly by Lx. We have got 1.667 as answer. Here it is. So rounding it, nearest value is 1.75 here. In this here in adjacent edge discontinuous 1.75, alpha x value is 0.84, 0.084 and 0.063. First one is negative moment and second one is positive moment for short span, and for long span straight to two adjacent edge discontinuous long span. Here they have provided 0.047 and 0.035 for long span. Only for short span we need Ly by Lx value to find alpha x data. Short span alpha x, we have got alpha positive 0.063 and alpha negative 0.084. Long span positive 0.035 and negative is 0.047. We must calculate for short span and long span positive and negative ultimate moment. First, for short span, formula is mu positive equal to wu alpha x1 into Lx square. Alpha x1 is alpha positive 0.063. Calculating in this, we get 6.36 kilonewton meter per meter. Next is for short span negative, we get minus 8.47 kilonewton meter per meter. Long span positive, we get 3.532 and negative minus 4.74. Next is ultimate shear force. Formula is ultimate load into effective span by 2. Answer is 16.28 kilonewton. Next step is main reinforcement. Here we have to calculate for long span and short span. Short span MUX formula is given in IS456 page number 96. Here it is. This is IS456 2000 page number 96. The formula is given here. It is 0.87 Fi AST into D into 1 minus Fi into AST by FCK into B into D. The answer for short span positive main reinforcement is AST equal to 183.11 mm square. For negative, AST is minus 224.17 mm square. And for long span, main reinforcement positive is AST 99.84, negative AST is minus 127.89. For short span and long span, positive and negative, we must find spacing. Spacing formula is small AST by AST into 1000. So for positive short span is 274.53, rounding it 300 mm. Negative is 224.25, rounding it 250 mm. Long span positive answer is 503.5, rounding it we get 500 mm. 393.07 is negative spacing of long span answer, rounding it we take 400 mm. Next step is calculating distributory reinforcement. Spacing formula is small AST by AST into 1000. Small AST equal to pi d square by 4. D is dia, 6 mm is taken. Answer is 28.27. AST equal to 0.12 by 100 into breadth into effective depth. Answer is 180 mm. Next step is torsional reinforcement. AST formula is 0.75% into AST of short span positive AST is 183.11. Calculating in this, we get 137.33 mm square. Small AST formula is pi d square by 4. D is 6 mm diameter. Answer is 28.27. Next step is spacing formula. Small AST by AST into 1000. Small AST we have calculated 28.27 and AST is 137.33. Calculating in this formula we get 205.89, rounding it 200 mm. So length of the torsion reinforcement is 1 by 5 of shorter span. Shorter span is 3000 given in the question. So length of torsion reinforcement is 600 mm. Next step is check for deflection. L by D basic is equal to 35. L by D actual is 3100 by 100. 3100 is effective span and effective depth is 100. We get 31 as answer. L by D maximum formula is L by D basic into KT into KC into KF. KT, KC, KF is provided in the table IS456 page number 38, figure 4. Answer is 1.2 for KT. KC is 1, KF is 1. Referring to the figure in IS456 2000, we get answer is 42. L by D maximum. So L by D actual is 32. L by D maximum is 42. Maximum 32 is less than 42. So the design is safe. Next is diagram of two-way slab. Two-way slab is here. Effective depth is 100. Overall depth is 150. Top is marked as main reinforcement. Bottom is distributory reinforcement. Thank you.